Let's list 3 uses for the multiplication property. First use, remove fractions. Remove fractions. Remove fractions by multiplying both sides by the least common denominator of all the fractions. Remove fractions by multiplying both sides by the least common denominator of all the fractions. Remove fractions by multiplying both sides by the least common denominator of all the fractions. An equation may have several fractions in it. We can remove all of the fractions at once by multiplying both sides by the least common denominator. An abbreviation for least common denominator is LCD. As we use least common denominator, I will probably use the abbreviation LCD to save writing. We'll multiply both sides by the least common denominator of all the fractions in the equation. Use number 2 for the multiplication property. Remove a coefficient. Remove a coefficient. Remove a coefficient by multiplying both sides by its reciprocal. Remove a coefficient by multiplying both sides by its reciprocal. Remove a coefficient by multiplying both sides by its reciprocal. The coefficient may be a fraction, maybe 3/4. We can remove a coefficient 3/4 by multiplying both sides of the equation by its reciprocal. The reciprocal of 3/4 is 4/3. If we chose to remove the coefficient 3/4 by this process, we would multiply both sides by 4/3. If the coefficient is, for instance, 5, we could multiply both sides by its reciprocal. The reciprocal of 5 is 1/5. We can multiply by 1/5 to remove a coefficient of 5. But that leads us to the third use, which doesn't sound like the multiplication property at all. The third use is remove a coefficient by dividing both sides by the coefficient. Remove a coefficient by dividing both sides by the coefficient. Remove a coefficient by dividing both sides by the coefficient. If the coefficient is 5, we can remove it by dividing both sides by 5. If the coefficient is -10, we can remove the coefficient -10 by dividing both sides by -10. Let's look at examples that illustrate all of these uses. Our first example, x/3 equals -5. x/3 equals -5. Our goal in solving the equation is to have variable equals constant. The variable x should be alone when the problem is completed. Now x is not alone. X is over 3. X is divided by 3. This is an example of a problem that has a fraction, x/3. We can remove the fraction by multiplying both sides by the least common denominator of all the fractions. -5 is not a fraction. It has an understood denominator of 1. The only fraction that appears in fraction form is x over 3. The common denominator is 3. We can multiply both sides by 3, and we do exactly that. Multiply both sides of the equation by 3. 3 times x over 3 equals 3 times negative 5. 3 times x over 3, the 3's can be reduced. 3 goes into 3 once, 3 goes into 3 once. This gives us 1 times x over 1. 1 times x is x. X divided by 1 is x, and so on the left side we have simply x. On the right, negative 15. So our solution is x equals negative 15. The check goes in the usual way. For our check, we copy the equation x over 3 equals negative 5 and make the usual t format. X over 3 equals negative 5. The t format has space for the left side and for the right side. For the left side, we replace the variable x with the number that will be filled in for it. Over 3, on the right we have simply negative 5. The x number we're testing is negative 15, so we'll fill in negative 15 for x. Negative 15 divided by 3 is negative 5. On the right we have negative 5 to start with, and so the check is quick and correct. That means that our answer is x equals negative 15.